Hello, in this lecture I will try to answer the question, is the universe infinite? What is the universe? The universe is all of space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. The Big Bang theory is the prevailing cosmological description of the development of the universe. The Big Bang event is a physical theory that describes how the universe expanded from an initial state of high density and temperature. According to this theory, space and time emerged together 13.8 billion years ago, and the universe has been expanding ever since the Big Bang. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is approximately 93 billion light years in diameter at present day. It is impossible to know for sure if the universe is truly infinite. The observable universe is definitely finite. It is that part of the universe which is within 13.8 billion light years of us. The number 13.8 is because it has been 13.8 billion years since the Big Bang, so any part of the universe that is more than 13.8 billion light years away from us will not be visible or observable, since the light from those areas cannot have reached us by now. Cosmologists assume that there is a significant part of the universe that is outside of our observable portion of the universe, but it is impossible to say for sure that it is infinite. The standard cosmological assumption is that the universe is homogeneous and isotropic. That is to say, it has no privilege or unique point. These assumptions seem to be correct and is confirmed in our observable universe. The universe looks the same in all directions, and on a large enough scale, the universe seems to be homogeneous. If the portion of the universe that is not observable is also isotropic and homogeneous, then it could be that the universe is truly infinite. One piece of information that is needed to determine if the universe is infinite or not is to know the curvature of the universe. There are three different regimes of curvature. It could have a positive curvature, which is like two-dimensional curvature of the surface of a sphere, like here. That is to say, the universe closes inward and it is finite like the sphere. Another possibility is that the universe has zero curvature, which is like a flat plane. Then the universe is not closed but infinite, so it is like a flat plane, and in this situation the universe is infinite, and as I said, has zero curvature. The third possibility is that the universe has negative curvature, which is like the curvature of the surface of a saddle, like in this picture, the saddle. So it is negative curvature. Actually, the saddle is not closed, so actually it continues endless. So the universe, according to this, is that the universe is infinite. Then the universe is not closed at all and it is infinite. Yes, like the saddle that is not closed. If the universe is isotropic and homogeneous, and the curvature of the universe has a constant positive value, then the universe will be finite, just as the surface of a sphere is finite. On the other hand, if the curvature of the universe is a constant of 0, yes, it is then it is flat plane, or constant negative curvature. That is to say, the universe opens outwards and never closes, like the saddle. The universe would be truly infinite. So the universe would be infinite if its shape is like the saddle, or its shape is like a flat plane. And the universe would be finite if its shape is like a sphere that is closed. Okay, so do we have any measurement of the amount of curvature that the universe has? Yes, there is. The standard model of cosmology, which successfully fits all well-measured cosmological information, as a parameter total omega, which is related to the curvature. So total omega is actually a number that describes how much the universe has a curvature. Has it a positive curvature that is closed inward, or has it negative curvature that is opens outwards and never closes, or it can has zero curvature And then the universe is like a plane, flat. Okay, so if total omega greater than 1, then the universe is positively curved. Like the sphere. If total omega exactly equals to 1, the universe is a flat plane, and if the value of total omega is less than 1, the universe is negatively curved, like the saddle. The best measured value of total omega is total omega equals to 1 plus minus 0.12. Okay, so if total omega equals to 1 plus 0.12, that is 1.12, that is greater than 1, then the curvature of the universe is positive. Total omega is greater than 1. The curvature is positive, and the universe is in the shape of a sphere, and the universe is closed. Yes, if total omega is greater than 1, then the universe is closed. If total omega equals to 1 minus 0.12, that equals to 0.88, that is to say total omega equals to 0.88, that is less than 1. So if total omega is less than 1, then the curvature of the universe is negative, and the universe is in a shape of saddle, and the universe is infinite. So I repeat, if total omega is less than 1, then the universe is infinite. And the same thing, we can say that if total omega is equals to 1, that is a flat plane, and the universe is also infinite. Which obviously could encompass everything from positive to 0 to negative curvature. So there is no definitive answer at this point, but the universe is consistent with having 0 curvature, because total omega is actually 1 plus minus 0.12, so it is close to 1. So we really don't know if the universe is infinite at this point, but since the value is close to flat, because it is close to 1, even if the universe is positively curved and finite, it would definitely be much, much bigger than the observable universe. So we can summarize that the size of the universe beyond the observable universe is unknown, since it cannot be observed. at the moment we don't even know if it is finite or infinite. But there are speculative estimates by theoretical physicists who say that the size of the universe beyond the observable universe should be at least 250 times larger than the observable universe. Other estimates speak of a universe whose size is even inconceivably larger, even if still finite. Okay, thank you very much.